Hi, this is Alex from devstories.eu. LangChain v1.0 Orchestration Framework, Episode 16 of 20. When your single AI agent starts to fail because of its own massive list of tools and competing instructions, throwing a larger context window at it will not fix the problem. It is time to stop building a monolithic script and start hiring a team. That is exactly where the multi-agent paradigm comes in. We build multi-agent systems because single agents hit a cognitive wall. Give an agent 30 tools, 5 pages of system prompts, and a long conversation history, and it will lose focus. It will call the wrong tool or forget constraints. The multi-agent approach breaks this down. It enables distributed development where different teams manage different agents. It allows parallel execution. Most importantly, it enforces strict context isolation. Today, we focus on a specific architecture called the Subagents pattern. This involves a main supervisor agent that delegates tasks to specialized subagents. People often confuse a supervisor with a simple router. A router is just a static function that looks at a query and sends it down one fixed path. A supervisor is an active thinking agent. It maintains the conversation state, decides which subagents to invoke over multiple turns, and synthesizes their responses. Here is the key insight. Subagents provide perfect context isolation. When the supervisor asks a subagent to do something, the subagent boots up with a completely clean context window. It only has the specific instructions and tools it needs for its exact job. The subagent might make mistakes, call tools 3 times, and fill up its own scratchpad while figuring out the answer. The supervisor never sees that mess. It only receives the final cleaned-up result. This protects your main agent from context bloat and prevents hallucination. To connect the supervisor to the subagents, you wrap to subagents as tools. There are 2 ways to do this in LangChain. The first method is tool per agent. You give the supervisor a specific tool for every subagent. If you have 5 subagents, the supervisor has 5 tools. The second method is a single dispatch tool. Here, the supervisor gets exactly one tool called something like delegate task. This tool requires 2 inputs, the name of the target agent and the task description. Consider a single dispatch scenario. You have a main agent, a research agent, and a writer agent. A user asks for a complex market report. The main agent decides it needs data first. It calls the single dispatch tool, passing the research agent as the target and the market query as the payload. The research agent spins up in its own isolated context, searches the web, parses documents, and returns a summary paragraph. The main agent receives this text. Next, the main agent calls the dispatch tool again, this time targeting the writer agent, passing the research summary and formatting instructions. The writer agent drafts the final report and returns it to the main agent, who delivers it to the user. You can execute these subtasks differently depending on your needs. You can run subagents synchronously, where the supervisor waits for the research agent to finish before taking any other action. If you have independent tasks, like researching 3 different competitors, you can run subagents asynchronously. The supervisor dispatches all 3 tasks at once. They execute in parallel, and the supervisor waits for all of them to return before moving on. Grouping tasks into subagents is not just about organizing your code, it's about strictly controlling what the language model is forced to hold in memory at any given moment. That's all for this one. Thanks for listening, and keep building.